You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. We're coming to you from Boston, Massachusetts. Today is March 6th, 2026. Hope everyone is doing well and staying safe. Bhavin, let's dive into it. How you doing?
I'm doing good. Yeah. The weather is finally improving. I think I'm done with winter. I don't know, for a month at this point, but we did get that big snowstorm in February. I was complaining to all my friends here in California, in India, and then I saw your text and you said, "Yeah, you got twice or thrice the amount of snow I did." I was like, "Okay, I need to shut up now." And
Yeah, we were near the epicenter, right? I'm a little south west of Boston and basically right on the Rhode Island border, but we got 27 inches of snow, over 2 feet of snow. Is a lot of snow. And just south of us in Warwick, it was like 31. And then in Providence, I think 37.1.
Yeah.
So almost 3 feet of snow. And that's a half hour away from me, right? Yeah, a lot of snow. And speak for yourself, because it snowed and iced this morning out here.
Yeah, it did. Like I think we got like a couple of inches, but couple of inches. It's so funny that I'm at this mental state that I don't even think about it. Yeah, that's easy to shovel. Like it will take me 20 minutes, but I can get it done. When we're talking about, I don't know, 12 inches, more than 15. Yeah, like whew, I don't know. I'm very thankful to my neighbors, dude. Like they have snow blowers, and I didn't get one in time this year. I underestimated it. Like Boston
That
winters haven't been that harsh.
yeah,
And
that
then I was like, no, I can manage with a shovel. It's okay. I've been shoveling for the last 3 years. And no, this time it was a really wrong decision. I think when we got that
big pack.
18 inches, yeah, yeah, the neighbors saw me clear just one line in 10 minutes, and just the amount of work. He's like, wait. And he just brought a snowblower
He's
and
like,
took 5 minutes to clear my entire driveway. I was like, thank you.
it's
I'll
like,
buy
what
you
a
beer.
homeowner this guy is. Doesn't you know how to clear his driveway? Yeah,
I know.
no. What's funny is I read a bunch of statistics about how the amount of snow this year was actually more on par of what a New England winter should be. Meaning,
Oh,
this is how a New England winter is.
yeah.
But
Where
we've
is
been
all that global warming, man? Come on.
right. We've had so many mild winters, especially
Yeah.
since, I think since like 2015 or so, that
Yeah.
we've just grown accustomed to like, oh, it's we can see the brown grass all winter. We haven't get used to all this, and this is just more like what it is supposed to be. Yeah,
Yeah.
no, I'm ready though. I think Tuesday is supposed to be like 60, and I can't wait. And people, I know, like folks in California are probably just laughing, But I love the season still. I wouldn't trade it for anything. That being said, we do have to deal with the snow, but everybody's got something to deal with in terms of
Yeah,
life.
no, no, no. Next year, when I'm prepared, I'll be there with you. This year, I'm just in that complaining mode that, hey, this is not what I signed up for, kind of a thing.
Not an ad, but I love the Husqvarna blowers.
Okay, send me a link after this. Yeah, because I want to bookmark it, and if it is in stock right now, order it right now, just so that if we get like second winter in March and April, and we get another storm, I want to be ready for it.
Yeah, Husqvarna or Aaron's are like top two brands, I would say, which is ironic because I have a Troy built that I got for $200 off of someone on an estate sale because I didn't want to spend a lot of money. And my neighbor plows, and I was just like, I just need something to like.
Yeah, yeah. Sure,
So
I'll do it.
that being said, it started spewing oil on the last snowstorm.
Oh, okay.
So you get what you pay for, Bobbin. You know.
Yeah, yeah.
All right. Well, we do have a fun episode today. We're diving into the whole world of VMs on Kubernetes and sort of
Mhm.
what probably is top of mind for a lot of VM admins out there, asking themselves, what is it? How does it work? What skills do I need to learn? How mature is it? Broadcom is going through a lot of changes, and my company's, not renewing or only renewing for so long. We're gonna figure out what's next. And Janakiram MSV, who is an architect, an analyst, a previous guest of Kubernetes Bytes, and overall just a Kubernetes guru and expert, in my own words there, is going to come talk to us about this topic. All right, welcome back, Johnny. I say welcome back. It's been probably a few years, I think, since being on the show. I'm not sure exactly the date of that show, Bhavin, but I'll have to look that up. It's great to have you back. I know we have an exciting topic talking about sort of the world of virtual machines in the context of Kubernetes, and where that's come in the last year is really from down here to way up here. So we're excited for you to kind of dig into that. But why don't you reintroduce yourself for our new listeners?
Well, thanks for having me. It's great to be back into the show. I think the last time we discussed in Kubernetes Bytes was about AI ML workloads running on top of Kubernetes.
That's right.
It's been a couple of years, and now it's all about LLMs and fine tuning and running inference on top of Kubernetes. Well, we are going to talk more about VMs, but let me start by introducing myself. My name is Janakiram MSV, based out of Hyderabad, India. Been working on Kubernetes since 2014, 2015, deploying the guest book, The Hello World of Kubernetes, on various flavors of Kubernetes. And I am a CNC of Cube astronaut, spoke at multiple KubeCons, very passionate about microservices, Kubernetes, and running AI workloads on Kubernetes.
Oh yeah, you were one of the main steering committee members for KubeCon India as well, right? If I remember correctly, and participating in the KubeCon India keynotes.
Yeah, I did two keynotes, the first two KubeCons in India. One was in Delhi last year, and more recently, the KubeCon in Hyderabad, in my home city.
Gotcha. Oh, that's awesome. That means less travel for you. I know you. We have seen you at multiple of these conferences across North America and Europe. If a conference happens in your city, that's always great. Like we can vouch for that when Red Hat Summit happens in Boston.
That's right.
Absolutely.
Okay, so Johnny, I'll kick off the questions. So for listeners, I new or old, as Ryan said, that are coming from the traditional VMware background, right? How would you like describe Kubernetes to them through a VM admin's lens, right? Because they have spent maybe 15 years, 20 years using vCenter, using all the VMware tools and tooling around it. How do you describe Kubernetes to them?
Yeah, the best way to map what you already know with Kubernetes is thinking of Kubernetes as vCenter reimagined, but for cloud native era, right? So
Yeah.
vCenter is at the front and center of VM orchestration, and that is the go-to console for all the VMware admins. Whereas when it comes to cloud native microservices and containerization era, it's Kubernetes. So it's primarily Kubernetes that orchestrates containers, pods, and basically the compute. So instead of managing VMs on ESXi host, you are essentially managing containers and pods on nodes. So the best way is to compare and contrast vCenter with the Kubernetes cluster and the control plane together. So that is the best way of mapping. But fundamentally, I think the deeper shift is transitioning from imperative to declarative management. Most of the vSphere and vCenter folks are very comfortable with TCOPS. They click here, there, and get the job done. Whereas what will put them slightly off the gear is the reason to deal with YAML files, right?
Yeah.
So you have to basically understand how YAML functions, and then taking it one level above GitOps. So you basically commit YAML files to a Git repo, and then the controller will reconcile. So the shift is basically from the mental model of using a GUI to using YAML files and then eventually GitOps. But what remains the same is the layered mental model. You still have compute, you still have storage, you still have networking, management, right? Those four layers are exactly how
Sure.
things are structured even in Kubernetes world. So they are not very different.
Yeah, that's a good point that there's a lot that maps sort of higher level conceptually when you start to dig in and start to look at how it's implemented and get into the YAML, I think is where a lot of the differences come in. But those higher level kind of mappings do, I think, will help a lot of VM administrators
Mhm.
coming to Kubernetes. Now there is sort of a main project that's backing a lot of this movement in the Kubernetes space, right? This is KubeVirt. And the question I want to ask you is sort of in your opinion, why did we see KubeVirt emerge and sort of what's it kind of what gap is it really solving for us in the Kubernetes space, and why is it important to those VM admins?
Right, right. So there are two key factors that led us to KubeVirt. The first is Kubernetes started to transition from orchestrating just containers and pods to orchestrating a lot of things, including
Mhm.
cloud-based VMs through control plane and cross plane,
Oh,
cloud
right. Yeah.
resources, and then WASM, uh,
Ooh.
and edge clusters, and even clusters using CAPI, right? So there has always been this thought process that why not Kubernetes orchestrate VMs? So since 2019, KubeVirt has been an incubating project under CNCF umbrella. So
Mhm.
it's been in the works for a long time. That is one. So the community and the ecosystem always wanted some convergence between VMs and containers. So that was in the works.
Sure.
What actually accelerated that was Broadcom's acquisition of VMware in 2023, right? Then the dramatic restructuring of the licensing model and all the conversations around the new cost structure only accelerated the maturity of KubeVirt, and what was moving along slowly took up a faster pace and became much more mainstream and much more matured. So these two factors, right? One, the intention of Kubernetes becoming the control plane, not just for pods and containers, but for VMs on one side. And then the
Mhm.
factor that actually accelerated this whole process is Broadcom's acquisition of VMware. So these two basically made KubeVirt what it is today. And KubeVirt is basically the bridge between the cloud native ecosystem and the VM ecosystem.
Yeah. And KubeVirt, it's not like the community just built all new software to make KubeVirt happen in 2019 since it's been incubating, right? It's based on existing technologies that have been around a long time, right?
Yeah, absolutely. It builds upon the primitives of Kubernetes. It is not a foreign entity to Kubernetes. It is very well integrated, and it takes advantage of various primitives, which we'll discuss in our conversation. Various primitives that are already proven in the Kubernetes architecture and the ecosystem. So it just relies on some of these developments and some of the innovations that took place in the Kubernetes world, Kubernetes ecosystem.
Yeah, and as far as virtualization technology under the covers, right? I'm sure VM admins are familiar with things like KVM and QEMU and those kind of things, which are have been in the Linux ecosystem for a very long time, and actually are were KubeVirt builds upon those, not just building upon the primitives in Kubernetes, but hey, we're not rewriting a new hypervisor here. This is not what we're trying to do necessarily.
Absolutely.
Uh, yeah.
Okay, so I think more on the hypervisor front, right? I wanted to ask you, Johnny, that is Kubernetes kind of the only solution? We always see in the industry, obviously, when we're scrolling through LinkedIn, right? There are so many different vendor solutions out there. Like Kubernetes slash KubeVirt is one of them, but then there's obviously Nutanix, there's Hyper-V, there is different flavors of KVM. So I know Brian and I are biased because of Kubernetes Bytes. We would want Kubernetes as the next stack. But what advice would you have in terms of both short-term planning and long-term planning to people that are going through these evaluations right now and figuring out, is Kubernetes replacing their virtualization stack, or is it just becoming the new control plane to orchestrate things? Like how would you advise some of our listeners here?
I'm actually as biased as you. or maybe
Okay.
slightly more.
Get like a Hyper-V guy on as well in the
As
next
long as we're
episode.
verbally saying we're biased here.
Yeah.
So, yeah, after all, this is the Kubernetes podcast, and all of us acquired those stripes of Kubernetes over a period of time. So, see, I have been advocating Kubernetes as the universal control plane for a long time. I've been one of the biggest advocates saying, let Kubernetes become your universal control plane, orchestrating every entity that is running in a distributed mode. And my
Mhm.
most recent uh, at KubeCon Hyderabad in the most recent KubeCon India was Kubernetes as the orchestrator for AI agents, right? So I fundamentally believe Kubernetes has matured and reached an inflection point where it can pretty much orchestrate any resource. Now,
Hmm.
that resource is defined by the ecosystem, the developer, the DevOps engineer, but VMs are very well structured to become a subset of the Kubernetes control plane. So it is the new control plane. The hypervisor isn't going away, but
Right.
the KVMs of the world will still do the heavy lifting underneath. But what is changing is the management layer on top. Kubernetes
Hmm.
is absorbing and kind of subsuming the responsibility and unifying how VMs are typically dealt with, the life cycle, and how you manage everything else. So, and it's not the first time. When Kubernetes was launched, everyone thought it is typically meant for stateless
State.
workloads,
Yeah.
right? But then we have seen how Kubernetes has become the platform for stateful workloads. And I'm talking to two advocates and evangelists who are representing NetApp and
We agree.
Workworks. So, you completely agree with me that, stateless workloads are first-class citizens on top of Kubernetes. And
Mhm.
uh, in a way, Kubernetes subsumed that functionality. And,
Yep.
and today is all about virtual machines, and the universal control plane definition just logically and naturally extends to virtual machines. So the bottom line, Kubernetes is not replacing virtualization, right? It
Mhm.
is just becoming the control plane. Virtualization is a parallel technology. I would actually visualize the run C, which is at the bottommost layer of the stack with KVM, sitting on the same node. So you have run C to basically handle the life cycle of containers. You have KVM to handle the life cycle of virtual machines. And just
Yeah.
like run C talks to the container runtime interface and surfaces containers and pods all the way up through deployments and stateful safes, you have KVM's assets, which are virtual machines, surfacing through all the layers of Kubernetes and becoming
Mhm.
available as deployment objects, which are like virtual machine and virtual machine instance types.
Yeah. Yeah, I think the one of the questions that I do get right is eh, obviously VMware, because of its history, has had so many years of head start on Kubernetes as the VM orchestration platform, right? So there are features that are not there. So I think I really like the way that you put it, that it's a control plane. Like virtualization is one of the tenants, right? Like yes, virtualization is one of the things that we'll orchestrate, but if you look to the future, nothing is stopping you from adopting containers if you're coming from VMware. Nothing is stopping you from using the same orchestration layer for deploying those AI agents. So we'll definitely link that keynote, that talk that you did, Jani, as part of our show notes. But yeah, I think that's the key essence, right? It is the control plane, and it doesn't really matter what the workload is today. Like I know 2 years back we were talking about how AI is running on Kubernetes. Now you're talking about how VM is running on Kubernetes. I'm sure we'll have you back in 2 years to talk about some other new workload that's running on Kubernetes. So I think yeah, that really helps. No, thank you for sharing that.
Right. So I do want to dive in a little bit to how things actually work, right? For the practitioner that might be listening. Um, and so let's dive right in and talk about how a VM actually runs inside of Kubernetes. We mentioned KubeVirt, but maybe from a high level, let's talk through in sort of your mind map here,
Mm.
Johnny, how a VM actually runs inside Kubernetes with KubeVirt.
Absolutely. So basically, KubeVirt wraps a KVM virtual machine inside a pod. Now that is the fundamental unit of deployment or the unit that you can deal with. So
Mhm.
KVM VM running inside a pod. That is the first way of visualizing it. And then there is what launcher, the pod that basically owns the VM process and the KVM hypervisor, uh, where the actual action takes place. So the word launcher pod is responsible for owning the VM process, and KVM still does the heavy lifting. So from Kubernetes perspective, it just sees a pod, but from the guest OS perspective, it's just a VM. So that is the beauty of this architecture, right? So when you take a node, and as I said earlier, if you peel off all the layers of Kubernetes, you will actually hit run C at some point. Run C is the bottommost layer of this architecture, right? And similarly, you have the KVM as the bottommost layer of this KubeVirt stack. Now, all the heavy lifting will be still done there, but the KVM virtual machine is now wrapped inside a pod, and for all practical purposes, that is still a pod. But you can actually do kubectl, get virtual machines and get virtual machine instances, and you can still see them alongside pods. So double clicking on this, the architecture basically has three main components, which you need to know. And it's very difficult to explain this without a slide. I would typically whiteboard this, but let me attempt explaining this in a podcast, right? So the Word API server handles incoming API requests and validates the VM object. So that is basically the external facing API layer responsible for accepting the request to launch a VM. Then the what controller, right, is responsible for watching the virtual machine objects and it reconciles them. Now think of this like a controller. It's the loop that basically manages the life cycle of a VM wrapped inside a pod. And then the word handler, it's a daemon set, that runs on every node and uses libvirt to talk to the underlying hypervisor. So these are the three important things. So every node has a daemon set, which is negotiating underlying virtualization layer, which is KVM, and it actually communicates with another tiny layer called libvirt, which is responsible for actual processes. Now, as I said, it's a little bit challenging to explain this
You're doing a good
without a
job.
whiteboard, without a slide, but these are basically the essential building blocks that you can think of. And then there is a crucial difference or distinction between a virtual machine object, which is the persistent desired state like a VM, and then there's a virtual machine instance, which is the runtime of the virtual machine. So you have a virtual machine that defines the state, how it actually should look like, and then there is virtual machine instance, which is the runtime of the actual virtual machine, which represents a running instance. So, this entire separation enables graceful restarts, live migration, declarative power off, everything that you typically do with a VM, but it goes via the pod, which is wrapping the VM within Kubernetes.
Interesting. So I think one follow up on that front, right? It's very because it has so many moving parts, right? You described a pod, a virtual machine instance. If I'm coming from a VMware world, right? I deploy a VM and then I see the VM and I see the VMDK files that are attached to it. How do we map that? Hey, this is what a VM encapsulates to a Kubernetes environment. So you started with the three, but are there other things that form the storage and networking layers that are needed by a VM to function as well?
Yeah, definitely. But before we get there, you actually open a blank editor, and you start writing a YAML file to represent your virtual machine, and that's going to define your VM. This is like a template. Think of the template in the VM world, and here the YAML file essentially defines the characteristics of the virtual machine, and the kind is going to be virtual machine. So you start with that, and then you apply that to your Kubernetes control plane, like the way you apply any other YAML file, right? A spec. And then it goes through these layers that I explained earlier to turn that into a virtual machine instance where you are turning on the definition that you have declared in the YAML file into a running instance.
Gotcha. So I just have to define the VM spec. Everything else Kubernetes takes care for me.
Exactly. Now let's talk about how it takes care of it, right? So now Kubernetes has these CRDs or custom resource definitions. If you want to bring any new type into Kubernetes, like deployment, stateful set, daemon set, or a job, you can define your own resource definition, and they are typically called as CRDs, custom resource definitions. So your VM is just a CRD called virtual machine,
Mhm.
right? And then it leans on pods for actual execution because pods are the fine-grained deployment units within Kubernetes.
Yep.
And then these pods have persistent volume for storage and services for networking. So it's not reinventing anything. It is basically composing what you already had into Kubernetes primitives, right? So now, if you want to go further and talk about the actual technology behind this, for
Mhm.
networking, KubeVirt is going to rely on multiple CNI to attach multiple network interfaces to the VM pods, right? Because this is this is how you basically replicate the multi-NIC pattern. It's very common in enterprise VMware environments, right? So you can attach multiple networks to the same VM, and you simulate that in Kubernetes through a specialized CNI, the container network interface called Multus. Now, that is
Okay.
going to help you map your network topology when you're deploying this in Kubernetes. And for storage, the most important aspect to understand is containerized data importer or CDI. Now, this component handles importing VM disk images from URLs, right? And from PVCs and container registries. And it basically creates persistent volume claims that the VM can consume.
Okay.
So this is going to create the persistence layer, which is like the VMDK that you attach to your VM to make it stateful. So CDI is essential for anyone managing VM storage because that is how you efficiently define the data path, for VM provisioning and all the performance characteristics that you typically define and spin up VMs, in the VMware environment. So to summarize, there are CRDs that bring you new types called virtual machines and virtual machine instances.
Mhm.
Then there is multi-CNI that maps you to how do you perform networking in the VMware environment. And then you have the CDI, which is the containerized data importer for managing the state and the storage for the VM. And then finally, you have the CDI, which is also managing your data path, for VM storage.
Mhm.
So,
So
uh, mm, go ahead.
yeah, on the CDI front, right? Is it just for my boot disk, quote unquote, or is it also for my data disk? So if I'm deploying a VM from, let's say, an Ubuntu template, right? Is it just going to create my boot disk a small PVC, maybe 10-20 gigs, or can I customize it and use it as for a 200 gig PVC, a terabyte PVC, and there will be partitioning somehow underneath it? Is all of that controlled by CDI? What if I need a second PVC? Does that also need to be a second CDI instance?
Yeah. So every time you want to bring a stateful VM into Kubernetes, CDI is the way to map that.
Okay.
So it is not just for the board disk. Any additional stateful disk for storage that you have attached to the VM will also go through the path of CDI.
Gotcha. Okay. Okay.
All right. So I wanted to look a little bit and double click on how VMs are actually sort of managed and scheduled into Kubernetes. We talked about sort of how they run and some of the concepts like pods and how data gets into them. But VM admins coming from the Broadcom and
Mhm.
sort of world might be familiar with DRS or storage DRS or vMotion, those kind of technologies. Now, how do these things sort of map to how Kubernetes schedules VMs?
Well, VMs are definitely more constrained than containers
Mhm.
because containers are stateless and they are extremely lightweight. So the scheduler has a lot of freedom on placing the containers wrapped as pods into any of the nodes. Now, the fundamental difference is VMs carry state. They are always stateful. if you
Yeah.
are bringing a SQL Server or a PostgreSQL VM or an
Yeah.
Oracle VM, which is a decade old, they carry a lot of state and they have CPU pinning requirements, right? You might actually want to pin the VM to a specific core or certain number of cores of CPU because of the licensing. Remember, most of these old software vendors, old school vendors still
Yeah.
sell per CPU licensing, right?
Yeah.
So you cannot randomly allocate number of CPUs and remove them at runtime. So CPU pinning is a very important requirement. And then there is something called non-uniform memory access or NUMA awareness, which again is very specific to the way the virtual machine is run on a host, right? Now that needs to be considered. And more recently, the GPU pass-through has to be addressed. Now,
Sure.
all these requirements make scheduling of VM within the Kubernetes environment very, very complex than throwing a container as a pod and ask that to schedule on any available nodes that meets the requirement. So this
Yeah.
is very different. So the scheduler now needs a lot of fins, right? So if it needs to handle node selectors, affinity rules, and requires a lot of deliberate configuration that will underpin the compute storage network needs of VMs than containers.
Gotcha. No, so Johnny, you brought up Numa, right? And those were the sessions at VM Worlds that I attended that I always skipped. Like I went to one of those and it was just too detailed. And yeah, I was like, I don't care about this. I just need my VM. So my question to you is, does KubeVirt as the project, open source project from the community handle these advanced scheduling decisions? Or is it like flavors on top, right? Like Red Hat OpenShift virtualization or SUSE virtualization. These guys are solving it. Like where is this problem being solved?
So let me answer this with a disclaimer. Right now, this is not something that I'm extremely comfortable or confident of answering, but my understanding is the core keyboard primitives handle the scheduling aspect of it. They are baked into it. But some of the commercial implementations like Red Hat OpenShift virtualization, SUSE, enhance that further. But KubeVirt fundamentally has these scheduling enhancements baked into its controllers and operators. So it is part of core KubeVirt stack, but it is certainly enhanced by commercial implementations.
Gotcha. And one more follow up. So Ryan, when he asked the original question, right, he was talking about DRS. And DRS was a really cool technology in VMware, right? Like it figured out the resources and then it moved VMs around, things like that. Does that capability exist today? I'm just trying for our listeners, right, to draw some mappings like, yeah, DRS box check. Like, does DRS, something like DRS, um, uh, exist on a Kubernetes environment with KubeVirt?
It's a very tricky use case to run on KubeVirt.
Mm-hmm.
You know, vSphere's DRS essentially rebalances workloads across hosts based on their utilization. Now, unfortunately, KubeVirt has no equivalent, when it comes to automatic load balancing and automatic scheduling of VMs across multiple nodes based on resource utilization. That is a capability may be expected from the commercial implementations at some point, but plain vanilla KubeVirt has no one-on-one mapping between DRS and the Kubernetes implementation.
Yeah, that makes sense. And there's some differences in actual implementation, right? The real-time data, the VMs sort of
Mm-hmm.
being acted upon versus how that works in Kubernetes. I think there'd be, a third party that would have to essentially manipulate as a schedule extension to constantly do that. And this is where I think, some of the exact like A to B mappings. I'm thinking about those
Yeah.
like tests in grade school, like match this one to this one. It's not entirely clear. It might be a little bit of a squiggy line, but like you said, a lot of the primitives to support doing those things are there,
Mm-hmm.
and we're definitely early days in this transition, right? So I think maybe this leads me a little bit to my next question is sort of as a VM admin who's maybe taking the leap or taking the step with their organization to start implementing VMs on Kubernetes. are there workloads that still shouldn't move to Kubernetes or KubeVirt? Or should they be kind of considering anything they have in their VM estate capable of moving to Kubernetes at this point?
So that's an interesting question.
That's why I'm asking you
So,
that question.
so anything that has very tight hardware dependency
Mhm.
uh, is not an ideal candidate to move to KubeVirt yet. And again, I'm not an expert on this, but the SRIOV, the single root IO virtualization networking, which delivers extreme throughput. Uh, Now those workloads cannot be ported as is to Kubernetes. They are they have quality of service, they have SLAs in terms of throughput, and those workloads cannot be easily migrated to Kubernetes. That is the second constraint, right? So with hardware dependencies is one, then SRIOV networking limitations is the second, and the third one is Microsoft licensing for Windows Server, right? That's a very nuanced complication that VM admins will have to deal with. Uh, so if you are running Windows heavy estate, there's a real compliance conversation, right? So moving Windows workloads to KubeVirt as is will open up a Pandora's box. So
Yeah,
you have to you have to understand how the licensing nuances work, what complications you're going to deal with. So to summarize, um, so types of workloads are still better running VMware as of now. One is workloads with very tight hardware dependencies and hardware constraints, workloads that demand high network throughput and demand real multi-NIC environment with dedicated network control planes and so on. Third
Mhm.
one is Windows workloads that are running on VMware. These are better left to VMware environments as of now, because we don't have a straight answer or a mechanism to run them within KubeVirt and Kubernetes world.
Gotcha. No, I think it's a fair point, right? And I know we are putting you on the spot with a lot of like blanket questions and expecting a black or white answer. So no, these are obviously like things that we have seen, or you might have seen in with the customers that you're working with in the community that you are involved with. So obviously, uh, this is not like a. I love when I listen to financial podcasts, right? They say, "Hey, mutual funds are subject to market risk," kind of a thing. If there
Yeah,
are workloads that you want to move
we're
to,
hand wavy. We're
yeah, move to open Kubernetes or OpenShift virtualization, right? Like, do ask those questions, right? Like, do ask those questions to the vendors that you want to work with or to the community. Do some research. There might be things that have changed since the time we do this podcast, and you might be listening to this in 3 months, and there is a new release, and some of these things are fixed. So obviously, as Ryan mentioned, right? Like early innings, lot of work being done in the ecosystem to move these things along. And talking about one of such projects and features, I wanted to ask about live migration. Like, I think one of the coolest demos when I started, I think I was an intern at NetApp. I saw the live v motion of a VM from one node to another node in a vCenter, and that was super cool. Again, I know it had been around for a while, but I was looking at it for the first time. So is there live migration in KubeVirt, and how does it work? Where does it fall short? Can you talk more about that cool feature as well?
Yeah, this is one area where there is a lot of work that needs to be done.
Yeah.
Because the what most of the network folks underestimate in the Kubernetes environment is the bandwidth requirement for live migration, right? Because it's a very common topology in Kubernetes to see two networks. One is the control plane network that basically connects the control plane master nodes for traffic. And then you have a workload network, which is typically meant to channelize the traffic for the workloads. So you very clearly separate and differentiate between the control plane traffic and the data plane traffic. The traffic that is used for Kubernetes administration, the traffic that is used for the network that is used for the workload traffic. Now, these two are very clearly defined. Now, when you actually bring in something like live migration, you need a dedicated network pipe just to perform VM migrations in real time. Uh, Now, this is not what Kubernetes is ideally designed for. It doesn't really have that kind of a network uh, backhaul to really perform live migration in real time. There will be a lot of hiccups, there will be a lot of friction when you attempt to do this, just because the network will choke and that will become the biggest bottleneck. But having said that,
Mhm.
um, the KMU live migration under the hood, which can be triggered through Kubernetes APIs, you can kind of simulate the vMotion, but it is not going to be smooth. It is not going to be as smooth as a live VM moving from one ESXi host all the way to the other while keeping all the clients connected. It's not going to be that seamless, but you can achieve this with some tweaking. But the disclaimer here is watch out for network performance and network bottleneck, uh, because Kubernetes doesn't have that dedicated network for live migration.
Gotcha. No, I think that's super important, right? Because yeah, just showing demos of live migration in KubeVirt is great, but yeah, when we are thinking about production environment, uh, all of these nuances definitely become important. So, Jani, a follow up question, right? Is it also because, again, I'm just trying to ask the most basic questions. In VMware, right? We had a VMFS data store where all the VMDKs were hosted, and then if your VM object is moving from one host to another, we didn't really have to move the storage as well, right? It was still a part of the same data store. In KubeVirt, we have different PVCs, and if it's read write once, read write many, like for especially for read write once, there is a lot of mounting unmounting that needs to happen for it to reattach to the new VM. Is that also some plays a part or not really?
That's an edge use case. That's like, uh, and again, in the context of migration, I'm yet to see this in action. To be very honest, this is something that I'm yet to see in action and actually configure it myself. So that's a very interesting scenario on what actually happens to the attached drives.
Gotcha. Okay.
Makes sense. Yeah, and I mean to your point, Bob and Johnny, right? Like live migration is part of it, and realistically, adopting KubeVirt, adopting VMs on Kubernetes, you're gonna want to do some testing, right? To your point, Johnny, get your hands on it. This goes for the same. This goes the same for anyone listening who's working on this, right? Get your hands on it. There's tools out there where you can do some sort of like benchmarking of things like bootstorms or VM creations and all sorts of things, or you can develop your own. But these are the things that you're going to want to know that you really didn't have to think twice about giving your current VMware a state, because like it's just been around for so long. So we encourage you to try to break things right in this ecosystem. Although it's come a long way. So speaking of that, I think the skill set that VM admins need does change a bit, right? A lot of the skills that VM admins are transferable, meaning how we think about VMs, how we do planning, how we manage things, but underneath the covers, how we implement doing those things might change how they used to do it. So the question for you, Johnny, is sort of like from operational skills for VM admins, what things should they learn first, and what can they like save for later?
Yeah, absolutely. So I have seen a lot of VM admins jump to CKA and CCAD exams and burning their fingers. Sorry for using that term. Like, yes, the problem is, Kubernetes has grown in complexity from where it started. And even for folks who are cloud native and cloud native first, Kubernetes is not easy to understand. It is complex. It has a lot of jargon, terminology, and lot of uh, nuances to deal with. So my suggestion to VMware admins, if they are transitioning to cloud native and Kubernetes, is to do two things. Number one, get your mental model right. In the sense, map out your compute, storage, network management layers to Kubernetes. Get that right. And when it comes to compute, make sure you understand the basic control plane architecture. You need to be able to define what is a controller, what is a scheduler, what is HDFer, and what is the API server. How do they talk to each other, right? Now, this will take about a day or two to understand it well. And then you can start mapping the basic layers of your software defined data center, which is now VCF, to the Kubernetes ecosystem. Now, you need to be conceptually aligned in terms of how these are layered and how they work together. That is very architectural and strategic way of transitioning. Now, when it comes to hands-on and being very tactical, you got to get familiar with kubectl. There is no way getting around that.
No
Okay,
more click ops,
I
Johnny.
know. Come on, Johnny.
unfortunately, kubectl is your friend, and you have to master how kubectl works. So you have to understand various switches and various aspects of kubectl and get familiar with it. And then the third stage, slightly advanced stage, is GitOps, because GitOps is
Hmm,
very essential in production environments, and you need
sure.
to understand the combination of Git workflows with Kubernetes and how these controllers
Mhm.
actually work with reconciliation and desired configuration state and all of that. So that's slightly advanced. But summarizing what I said, get your mental model right. Number one. Number two, master the tools like kubectl, and make a couple of other CLIs that you are dealing with, particularly for using Portworx, Pixicatl. So things like that. And
Mhm.
then the third thing is GitOps, because GitOps has become the standard deployment route to any enterprise application. So understanding that is very essential. Those are the top three things.
Gotcha. Okay, no, I think that's a good way to summarize it. My only beef in that statement is you said you need to spend 1 or 2 days understanding the API server. I thought we just did in a matter of 10 minutes when you were explaining everything. Come on, Jati.
Everybody knows it now. Yeah.
No, but don't underestimate the complexity of Kubernetes control plane. It took
Yeah.
me a few months back in 2015 to understand, what are the components of control plane and how they talk to each other.
Oh yeah.
So 2 days is still less.
Yeah.
No, but
I
okay. So a question for you there, right? Obviously, the complexity in Kubernetes has increased, but weren't we having this discussion a few years back? Not you and I specifically, but the community overall. That hey, Kubernetes is supposed to be that abstraction layer, that platform where all the complexities are hidden, and all you need to do is focus on hey, how can you deploy things on top. So it's similar to like hey, only a few people in the ecosystem or a couple of people inside an enterprise organization might understand the nuts and bolts of Kubernetes, but then for everybody else it's supposed to be that platform. Similar to how not everybody has to know how an LLM model is trained and fine tuned and all of those things. They should know how to use those. Do you think that statement is still uh, valid, or people that are moving from VMware to OpenShift virtualization or KubeVirt generically still need to go to that next level of detail and figure out or learn everything to be successful?
So it's again a very complex, very complicated topic. It's not black and white. And I want to quote Kelsey Height over here, right? Kelsey, sometime in 2016, 27, when Kubernetes was still fairly new, made this statement saying Kubernetes is the platform of platforms, right? And it resonated with me back then. It still resonates with me today, because I was actually expecting someone in the ecosystem to build a platform as a service layer on top of Kubernetes, which will hide away the nuts and bolts of Kubernetes.
Yeah.
But 15 years later, we are still dealing with pods, deployments, stateful sets, services, load balancers, and service mesh, and the whole gamut of
Yeah.
controllers that we need to deal with. So the ecosystem hasn't been able to build a platform layer that abstracted the complexity of Kubernetes and gave a gig push to developers like a
Mhm.
Hero or Cloud Foundry. So that has remained an unaddressed or unsolvable problem, which is a layer for developers who do not want to understand what the nuts and bolts of Kubernetes is all about, right? We don't have the layer. And KubeVirt just kind of explodes that complexity further because you have to learn everything from the hypervisor all the way up to the virtual machine instance and everything in between. So the answer is we don't have a platform layer that magically hides away the complexity of Kubernetes. The closest that we got to is platform engineering and internal uh, development portals, right? At the most. But again, they are more of DevOps layers rather than platform layers targeting developers. They are still targeting DevOps engineers and SREs than developers. And KubeVirt is not an exception. KubeVirt, unfortunately, builds upon the complexity of Kubernetes and makes it slightly more complex.
Gotcha. Okay. Thank you for that candid, that kind of right when it comes to this new technology stack. So then, what's a realistic migration path, right? If I've gone through those trainings, I know what these different constructs are. I know how scheduling works. How do I plan out my migration? Because I'm not just running 5 or 10 VMs. It's in the order of thousands of VMs that I'm running inside my organization. How do you recommend customers go about this?
Yeah, it's definitely not a rip and replace, or there is no magic button that you can push to kind of see this happen, right? So remember, it's a transition and expansion and not a replacement. VMware is not going to vanish overnight just because KubeVirt has matured and the ecosystem is rallying around behind it, right? Uh, so the fundamental aspect is you have to understand this is going to be a side by side deployment and side by side environment for a long time to come, and then define your strategy very well. So first of all, you have to handpick those candidates that are less critical and have low friction to migrate and are fairly independent and not tightly coupled with remaining VMs. So identify those candidates and start performing the migration to KubeVirt. Those are the low hanging fruit, and those are the best candidates to target the transition and migration. And then eventually, once you gain your expertise and context level, create a transition plan and create a migration path to move your workloads one by one. So look at workload as an entity rather than VM as an entity, because
Gotcha.
mapping your workload as is to KubeVirt is more complete and mature and realistic than migrating one VM at a time. A VM is always a part of a larger workload and is delivering an outcome. So you have to think in terms of workloads and outcomes rather than individual VMs.
That makes sense. And I do want to mention that during this conversation we've mentioned that all the ClickOps is dead and those kind of things, and you have to learn kubectl, which you do, and you have to learn to love YAML and kind of dig into these details. But there are flavors out there that do have UIs that do help you manage VMs, and I think listeners will discover that as they look beyond just the KubeVirt project itself and into those different orchestration flavors. That being said, I don't know what the future looks like, Johnny. Maybe we will get to a place where people aren't using kubectl as much, and who knows? Maybe in 2 years we'll be talking about how kubectl with VMs is dead. I have no idea. Maybe that would make VMAVs really happy. I'm not sure, but I want to leave you with one more question before we start to wrap up here. And I know we had probably a list of like 100 questions that we could have talked about with this topic, but we do want to keep time in mind. So my last question for you today is going to be sort of what excites you about the convergence of VMs and Kubernetes and kind of where it's going.
Yeah. So for me, every time I see KubeVirt running inside Kubernetes, and when I do a kubectl get virtual machines, I feel I'm 2 steps closer to realizing the dream of universal control plane. That is the most exciting part.
Yeah.
I get a kick out of looking at pods and VMs side by side, and this has been the pipe dream for a decade. So that is finally happening, and it is it's happening in real time as we speak. So that is one. And second thing is, what excites me the most is the convergence of VMs and containers will accelerate the way we do ML, AI, and Gen AI stuff, right?
Sure.
So when we figure out how to do GPUs the right way with VMs running on top of Kubernetes, which is still a pain point at this time, we are going to have a uh, very hybrid or diverse set of solutions that will take advantage of partial workloads running inside VMs, partial workloads running on pods, and running the entire LLM workloads and pipelines end to end, spanning both pods and VMs together. And that is going to be a very exciting future. Where
Maybe even we can develop something that runs that way that can just help manage our VMs for us, right?
absolutely, absolutely, right? So now imagine a combination of VMs and pods handling your entire life cycle of data processing, pre-training, post-training, and inference, and all of that without you actually knowing which entity is taking care of the specific stage, right? Now, data scientists will access Jupyter notebooks without worrying whether it is a VM or a pod, and they do their job, right? And inference gets served out of the cluster spanning both VMs and pods, and the whole MLOps pipeline will cut across all these entities. That's a very exciting future that I dream of.
Well, on the next episode of Kubernetes Bytes with Janakiram, we'll talk about your AI and ML pipelines with VMs and containers. Well, Johnny, I do want to thank you as we wrap up here for coming on the show yet again to talk about such a fun topic. On behalf of Kubernetes Bytes and Bhavin and I, thanks again for joining our show.
My pleasure. Thanks for having me.
Thank you, Johnny.
All right, Bhavin, I always love talking with Johnny. He's so insightful and very thoughtful about kind of the way he
Honest.
technology, and very honest, which is good, right? At the end of the day, we're advocates here of technology, but we also are practitioners at the end of the day. So, Johnny's up to all sorts of fun stuff, and we were talking to him after the show, and suggested that he'll be on in a few months to talk about Gen AI and where that's come with VMs, and he's doing all sorts of fun stuff. If you're at KubeCon Amsterdam, go see Johnny's talk. That's all I have to say. I won't give any spoilers out. But,
Thank you for that. Yeah.
But yeah, Bhavin, I don't know if you want to add anything.
No, I think we're good. Let's wrap this up. Yeah.
All right. Well, that brings us to the end of today's episode. I'm Ryan.
I'm Bhavin.
Thanks for joining another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.